Two of America's most respected astronomers stood in a wood-paneled lecture hall in Washington and publicly defended completely different versions of reality, while neither of them possessed the one measurement required to know if either model was true. That was the dangerous part. In 1920, the most powerful astronomical institutions on Earth were confidently describing the structure of the universe while operating almost completely blind. Inside the Smithsonian Institution, under heavy chandeliers and surrounded by the country's scientific elite, Harlow Shapley and Heber Curtis pointed at contradictory chalkboard maps of the cosmos. One of them believed the entire universe was essentially the Milky Way. The other believed those faint spiral smudges seen through telescopes were separate galaxies scattered unimaginably far beyond it. And sitting quietly, almost ignored, was the one object that would eventually expose both men. A tiny flickering star buried deep inside Andromeda galaxy. At that moment, astronomy had reached an uncomfortable threshold. Telescopes had become powerful enough to reveal distant spiral structures in extraordinary detail. Observatories could photograph objects millions of times dimmer than anything visible to the naked eye. But there was a problem nobody could solve: distance. Astronomers could see farther than ever before. They had no reliable way to measure how far anything actually was. And that meant humanity's entire map of reality had quietly become a guess. For years leading up to that debate, Harlow Shapley had become one of America's leading authorities on cosmic structure. Using clusters of stars orbiting the Milky Way, he calculated something radical. Our galaxy was vastly larger than previously believed. Roughly 300,000 light-years across by his estimates. More importantly, he concluded our own solar system was nowhere near the center. Humanity had already been displaced once by Nicholas Copernicus. Now Shapley was displacing Earth again. But his calculations created a dangerous consequence. If the Milky Way was truly that enormous, then those spiral nebulae seen through telescopes could not possibly be separate galaxies. They had to exist inside our own. The universe suddenly became smaller, contained, ordered. Meanwhile, across the country, Heber Curtis believed the exact opposite. Through observations at Lick Observatory, Curtis noticed something troubling. Spiral nebulae looked too organized, too structured, too independent. Some showed dark lanes resembling enormous stellar systems, entire rotating formations. They did not behave like local gas clouds. Curtis proposed something far larger. Each spiral nebula was an island universe. Entire galaxies existing independently beyond the Milky Way. The implication was staggering. Humanity's cosmic address might occupy only one tiny fragment of a far larger structure. But neither astronomer could prove anything. And that is where the real problem begins. The entire astronomical establishment had started functioning on theoretical assumptions because observation had outrun measurement. The telescopes were improving faster than verification itself. Astronomy had quietly entered a dangerous zone where authority was replacing evidence. Inside that Smithsonian lecture hall, the visual looked decisive. Dark wooden walls. Two experts confidently presenting incompatible maps of existence. Rows of scientists nodding along. But confidence was masking a catastrophic dependency. Nobody in that room could directly measure deep space. The arguments sounded mathematical. They were actually built on missing information. And for a brief moment, the scientific world accepted this as normal. Then a new tool appeared. At Mount Wilson Observatory, astronomers began using the newly completed 100-inch Hooker telescope. At the time, it was the largest telescope humanity had ever constructed. And suddenly, objects once seen only as faint spirals became sharper, more detailed, more dangerous. Because now astronomers had a chance to solve the one measurement problem everything depended on. The method involves something called a Cepheid variable, a star that brightens and dims at predictable intervals. Henrietta Swan Leavitt had discovered years earlier that the timing of this pulsation directly revealed a star's true brightness. And once true brightness is known, distance can finally be calculated. For the first time, astronomy possessed an actual measuring stick. Not theory, not assumption, measurement. And suddenly that forgotten photographic plate from Andromeda became the most important object in astronomy. Then came 1923. Edwin Hubble was examining photographs of Andromeda taken at Mount Wilson. On one glass plate, he noticed something unusual. A tiny point of light. It flickered, brightened, dimmed, then repeated. A Cepheid variable star. At first glance, it looked insignificant. A single, faint star buried inside a distant spiral cloud. But when Hubble performed the calculations, the entire scientific world lost control of its own map. The star was impossibly distant. Nearly 1 million light-years away, according to early calculations. Far beyond even the outer boundaries of the Milky Way. And just like that, the Smithsonian Lecture Hall changed meaning forever. Those two astronomers pointing aggressively at conflicting chalkboard maps had never been debating reality. They had been debating the limits of their own instruments. Shapley was wrong. The Milky Way was not the entire universe. Curtis was partially right. Spiral nebulae really were galaxies. But even Curtis had underestimated the true scale by enormous margins. The larger consequence hit harder than the discovery itself. For decades, astronomy's most trusted institutions have been confidently defining humanity's place in existence while lacking the ability to verify their most important assumptions. Their conclusions were not wrong because scientists were careless. They were wrong because observation had advanced faster than measurement. The instruments could see. They could not confirm. And that tiny flickering star inside Andromeda exposed something far larger than a new galaxy. It revealed that scientific authority itself had been operating beyond its own limits. The experts were not discovering reality. They were building reality around missing measurements. One faint star corrected the universe and proved certainty had arrived too early.